Solving systems by elimination. So we've looked at solving systems by graphing in a previous video. We've done solving systems by substitution in a previous video. This time it's going to be done with elimination. And the whole objective is to eliminate one of the variables off the bat. So for the first sample, 3x minus 4y equals 10 and x plus 4y equals negative 2. By looking at this problem here, you spot that these are opposite signs in the same number. Well, if you had lost 4 yo-yos and you found 4 yo-yos, that makes 0, which means these two terms can get eliminated off the bat to where x is only left. So that's what we're going to do with elimination, is eliminate one of the variables at the start. So if you were to look at this as your initial problem and you draw a bar line down here, if you had negative 4y plus 4y, that makes 0y. Well, 0 times y is 0, so that means it's going to get eliminated. Then 10 minus 2 is 8, and 3x plus, remember this is a hidden 1, plus 1x is 4x. Now you can see 0 times y makes that eliminated, so then it's 4x equals 8, because this guy left. At this point now you need to get x by itself by doing inverse operation, and since x is times 4, you divide by 4. What you do to one side, you do to the other. That means your x is equal to 2. What does that mean? That means for the answer, the solution, so remember the solution to systems is the point at which both statements would be proven true if you were to plug it in. It's also the point at which these lines would intersect. So this point exists on both of the graphed lines. So that means that 2 is the x position. Now we need to figure out y. How do we do that? Now you just go back, you have this, and you use the substitution method. You just plug it in. And you can pick any equation to plug it into. I'm just going to plug it into the first one. So 3 times 2 minus 4y equals 10. Now I need to get the y by itself by doing inverse operation. So 3 times 2 is 6, minus 4y equals 10. Move the 6 over, minus 6. Negative 4y equals 10 minus 6 is 4. To get y by itself, you need to divide both sides by negative 4. That means that y is equal to negative 1. So the ordered pair for the solution to these two systems, which makes both of these equations true, would be at 2, negative 1. The next problem for solving systems by elimination. This time, if you look at the problem, you have 2x plus y equals negative 5 and 2x minus 5y equals 13. Well, there's no actual way to eliminate anything off the top because these have opposite signs, yet the values are different. Now, these have the same sign, but have different signs. Same signs. They're both positive, but they also have the same number. So what do you need to do? Well, if you spot that they have the same number of x's, so 2x and 2x, what you can do is multiply one of them by a negative 1 distributed out so that you reverse the signs across the board. So for example, I'm going to leave this one alone. So 2x plus y equals negative 5. And for this guy here, I'm going to just put parentheses, the distributive property, and I'm going to multiply everything by negative 1. By doing that, negative 1 times 2x makes negative 2x. Negative 1 times negative 5 makes positive 5y. And then negative 1 times the 13 makes negative 13. So all you're technically doing is reversing the signs across the board. Now that you have done that, look, you can eliminate these two off the bat because you had 2x, but you lost 2x. So those are gone. Now, 1y plus 5y makes 6y. You lost 5 and you lost 13. That means you lost a lot. So that means same sign sum, take the sign, so it's negative, and then sum the numbers, which makes 18. Y is not by itself yet, so in order to do that, you must do inverse operation. So since times 6, divide by 6. Well, negative 18 divided by positive 6 would make negative 3. What does that mean? You now have one piece to the solution for the system. They're going to intersect at y equals negative 3, and if you were to plug in negative 3 where the y's are, it would be proven true. Now let's find the x. How do you find the x? You take what you just found and you plug it into any of them. I just plug it in to the first one or the one that I didn't mess with. So 2x plus, don't forget parentheses when you plug in, equals negative 5. Where did I get this? It's the first equation. Okay, now I need to solve. So if I have negative 3, how do I get rid of it? I have to add 3 to both sides. So 2x equals lost 5, found 3, different signs difference, take the sign of the larger. 5 minus 3 is 2, and since you lost more, it's negative 2. Now that I'm at this position, you need to get x by itself. How do you do that? Inverse operation. So since times 2, divide by 2, divide by 2. Negative 2 divided by positive 2 is negative 1. That is the last piece you need. That means the solution to these systems, which makes them both true, is at negative 1, negative 3. This is the solution. Next problem, x plus 2y equals 11, and then negative 3x plus y equals negative 5. Well, what you should notice is the signs are opposite, the signs here are the same, but there's no number either that matches. So what you can do is you can pick, again, you can work and look at the y's and say, oh, I can times everything here by negative 2 to get that canceled out, or to make it easier, notice this is already a negative 3 here. So if I just multiply everything by positive 3 on this one, then that will make it positive 3 and a negative 3. So again, your objective is to make the values the same number but opposite signs. So for this guy here, I notice that with my x's, it would be easier. Again, you could do it with the y's, but you're doing double step there. So I'm going to do it with the x. All right, and what did I notice? I noticed that with the first one, in order to get this to cancel out, I would have to multiply everything by 3. And I highly recommend you draw the distributive property up here so you spot what you did. That way, on my next step, I'm saving room and doing 3 times x is 3x plus 3 times 2y is 6y equals 3 times 11 is 33. So again, that just got me this equation. The bottom one, I didn't need to do anything to it. I don't need to write anything on the side, just drop it down. All right, now we're at the point where we can eliminate. You see that the 3x minus the 3x makes 0. So draw your line down, go ahead and add the terms. 6y plus 1y is 7y. And then you had 33, you lost 5. You're now at 28. At this point, your objective is to do inverse operation to get your variable by itself, to isolate it. So since it's times 7, do divide by 7, which you do to one side, do to the other. Your y is equal to 4. You have one piece of the solution. You have your y, which is at 4. Now we need to figure out our x. How do we figure out our x? You just go back and you just plug it into the original. And if you're worried about having this up here, just plug it into the second one, and you don't have to worry. It can be plugged into any of them, though, guys. It does not matter which one you plug it in. It will work. All right, now that I plugged it in, you just solve using inverse operation to isolate x. So since it's plus 4, do minus 4 to both sides. That gets eliminated. Lost 5, lost 4, lost 9 equals negative 3x. Now you need to get x by itself, so that means you have to divide both sides by -3. Negative divided by a negative makes a positive, so x is equal to 3. That means that the solution or the answer to these systems, the point at which they would intersect, is at 3, 4. And the next possibility that you might have, let's just say we're looking at the equation here. -5x plus 2y equals 32 and 2x plus 3y equals 10. Well, looking at both of these, I spot opposite signs, but there are just like no numbers that are the same, and both of them actually have coefficients. So I'm not going to be able to just multiply one of them. I'm going to actually have to figure out the LCD. So what I'm going to do is I'm going to pick the easiest route. I notice that these have opposite signs, so I'm going to focus on those guys. If there wasn't a pair that had opposite signs, all you have to do is remember to times one equation by a negative and then the other one by a positive. That way they have opposite signs. But right now I spotted opposite signs. So what is a number that -5 and 2 can go into? Well, what I can think of is they can both go into 10. Okay, so that's what I'm thinking of. I'm thinking of 10 as the LCD. And so what you have to do is say, all right, well, what times what will get you 10, because you're making it an equivalent. So they have to be the same value when you multiply the numbers. Okay, so I know I need to multiply this guy, distributive property, by 2. And I know I need to multiply this guy, distributive property, by 5. All right, 2 times -5 gets me -10x plus 2 times 2 is 4y. 2 times 32 is 64. So don't forget, you have to distribute it to all terms across the board. Now do the same thing with the next one. 5 times 2 is 10x. I know I did it correctly. Look, I got my elimination. 5 times 3 is 15. 5 times 10 is 50. Now at this point, I'm back to square one. I spot my elimination right here because lost 10, found 10 makes 0. I'm going to draw my line so that now I know I'm using elimination, and I'm going to add the terms. 15 plus 4 is 19y. And then you have 64 plus 50. 0 and 4 is 4. That is 11. So now you have 114, and it's divided by 19. Okay, so then what are you going to end up getting for this? When you divide it, you should get that y is equal to 6. What does that mean? That means you have the first piece to your solution. How do you get your second piece? You take that and you plug it in. All right, well, I'm going to go ahead and plug it into the original. Oops. 5x plus 2 times 6 equals 32. All right, now I know I need to get x by itself, so that makes 12 equals 32. And then you still have the -5x minus 12 minus 12, -5x equals 32, lost 12, you have 20. And then divide by -5, divide by -5 using inverse operation. Your x gets you -4. That's your other piece. So the solution to the systems here by using elimination is at -4, 6. All right, you have a word problem. Miss Vevick has $7.75 to buy 12 sheets of felt and cardstock for her scrapbook. The felt costs 50 cents per sheet and the cardstock costs $75 per sheet. How many sheets of each can Mrs. Vevick buy? Any type of equation with these systems with shopping, one equation will be the equation that equates to the price per item. The second equation will always be the one that equates to the amount purchased. So let's break this down. So for my first equation, I'm going to look for which ones talk about my money. So how much do I have to start? My total is $7.75. So that means it has. Has is the same as is. That means that's where my equal goes. Then I need to go find out what are my X and my Y's. What are we purchasing? Okay, I see money here as 50 cents per sheet for the felt. And then I see 75 cents per sheet for the cardstock. Wherever you see the word per, that means multiply, and then there's a variable. Wherever you see the word per, and then there's a variable. Now, you can think, do you want to make the felt your X and the cardstock Y? So let's pull out our given. So $7.75 is what I have to purchase felt that is 50 cents times whatever your felt is, plus 75 cents for each cardstock. Now, wherever we have felt, we're going to put our X there because we've determined that we want to make that the X. And then the cardstock, okay, I'm going to make that my Y. We have our first equation. The second one, the second equation, let's go through, and we want to see the amounts. Well, how much do I have to buy? What is my total? I must buy 12. That means that the total I have is 12. Now, where else do you see what we're buying? Well, I'm buying what? Felt and cardstock. Which means felt plus cardstock. So if I were to have this problem, I would expect this as your given to finally create your final equations, which would be 0.5 x plus 0.75 y equals $7.75. Notice you get rid of the dollar sign and the words. Your other one is X for felt plus Y for your cardstock is equal to 12 total that I must buy. Now you have your equation and you need to do elimination. Well, to do elimination, what you can do is you can either multiply your change up to make -1, or you can see that these are units of 1 and multiply these to make it -0.5. Well, how would you do that? If I were to look at x, this means 1. How do you get 1 to 0.5? You divide by 2, right? Which is the same as times -1/2. So to get my elimination, I am going to multiply everything down here by -1/2. So the first one, I don't do anything. The second one, what is -1/2 times 1? That's -0.5x. We should know that 0.5 is equivalent to -1. -1 times, again, positive, that makes it 0.5y. Negative 1/2 times 12 makes it negative 6. Now we're back to elimination. These guys are gone. I draw my line. 0.75 minus 0.5 gets me 0.25y. You had 7, you lost 6, that's $1.75. Now think in your head, how many quarters are there in $1.75? Because if it's y times 0.25, that means y times a quarter. So then divide by a quarter. Divide by a quarter. Well, there's 4 quarters at $1, and then 3 more for 75. So that means a total of 7. All right, so right now I know my y is 7. Then I must plug in to get my x. I always, for these, will pick this one because it's a lot easier. X plus 7 equals 12 minus 7 minus 7. X then, how many are left? 7, 8, 9, 10, 11, 12. You have 5 left. You're not done. You have to now answer the question, how many sheets of each can Mrs. Bevan buy? Well, what does my X stand for? My X was felt and my Y is cardstock. That means that Mrs. Bedvick can buy 5 pieces of felt and 7 pieces of cardstock. That's the final answer.